Good evening and welcome. I'd like to first start off by looking at a dead cell phone. Now imagine plugging it in, waiting 3 seconds, and having it fully charged and last you the rest of the day. Now some of you may say, this technology doesn't exist. That's impossible. We'll never be able to do that. Well, I am here today to explain to you a recent breakthrough in one of the key materials that would allow this technology to exist. This material is called graphene, and more specifically, graphene supercapacitor. Now, graphene is a polymer of pure carbon that is only one carbon atom thick. Now, graphene is one of the strongest materials on the planet. It's very flexible, and it's an excellent conductor. Now, people have known about graphene for decades, but we have never been able to create it effectively, efficiently, or reliably. Until very recently, at UCLA, a professor and his team were able to come up with a method to create graphene sheets extremely reliably and economically. What they did was they coated CD with a graphite oxide solution, so like a liquid carbon solution. They then placed the CD in an average DVD burn. And using the light from the laser and curing the carbon in a specific way, they were able to create graphene sheets that you could peel off the CD. Now, it was an amazing discovery, and what is maybe even more amazing is that the grad student then charged that unrefined piece of graphene for a few seconds with a small battery, and then attached it to an LED light, and that LED light stayed lit for over 5 minutes. Now, one of the main goals of these supercapacitors is to one day replace batteries. Now, batteries and capacitors are different in that batteries use an electrochemical reaction to produce a flow of electrons, whereas capacitors literally store electrons in positively charged areas of their structure. Meaning, though, that the capacitors are limited to the amount of surface area that the electrons can sit in. Now, one of the great benefits of graphene is that it has a huge surface area to weight ratio, meaning that graphene supercapacitors will be able to meet and exceed current battery energy capacity. And so not only will these graphene supercapacitors be able to store the same amount, or if not more energy than normal batteries, they will be able to be recharged in a fraction of the time. Like I mentioned before, a cell phone being able to be charged in 3 to 5 seconds. Imagine an electric vehicle arriving at a power station being able to recharge in a matter of minutes. It's incredible. Graphene supercapacitors are also made of pure carbon, meaning that they're biodegradable. We all know batteries are made of heavy metals such as lead and are disastrous to the environment. Graphene supercapacitors are biodegradable and can literally be thrown in the compost. And since they're made of carbon, it's an abundant material that can be found everywhere in the world. We could extract the carbon from the CO2 and again improve the overall environment. Now, because we've now discovered a low-cost production method of producing this high technology, it will mean that this technology is accessible to people all around the world. It won't be only limited to the richest of the richest countries. Now, one potential drawback of this technology is that it may increase our entitlementality, meaning that we may begin to expect cell phones should be charged in a matter of seconds. But overall, I believe graphene supercapacitors is the future. I believe it will replace batteries, and it will have a huge benefit in the overall world.